Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com. Welcome to Pressure Compensated Pump Adjustments Part 1. Assuming that you have some basic knowledge about the 9, sometimes 7 pistons in the cylinder barrel that are drawing in fluid through half of the shaft rotation and expelling fluid through the other half, let's now look at how this pump can vary its displacement, and let's look at the function of a controller mounted to this type of pump that is typically known as the pressure compensator. When you see the green highlighting appear, don't forget to have a look at the matching symbol in the upper right-hand corner of the screen. Other typical names for pressure compensator are pressure override and pressure cutoff. All of these terms describe a feature that may allow us to go without a relief valve, as is commonly found mounted to a T-fitting on the outlet line of a fixed displacement pump. Let's look at just a few common components that we will be speaking of throughout the video. The inlet line A is shown in violet, with the cylinder barrel assumed to be spinning as shown in the 3-dimensional mimic. And the pump output or discharge port is shown here at port B. This is the swash plate. There is also a very important component called the control piston, and a component known as the bias spring. The pressure compensator has an adjustment screw, a spring, and a compensator spool. The compensator has an inlet port that is monitoring the outlet pressure, as shown on this line with the jump tags labeled lowercase letter a, that passes behind the volume stop screw. We'll speak more about the volume stop screw to limit the pump volume output in a Part 2 video. We've installed a needle valve to act as a generic hydraulic system circuit resistance. In other words, closing down on the pump's outlet line is going to allow us to build system pressure on the pump's outlet port. On the controls, we have 2 adjustment dials, one coarse adjustment and one fine adjustment, but they ultimately both control the same needle valve. Using the 2 different dials is just for teaching convenience. As you know, a needle valve typically has only one adjustment. A flow meter will indicate flow rate, and a pressure gauge will indicate system pressure. Starting out, the pump is producing 10 gallons per minute, which is its maximum value, and the system pressure is at a low value of 100 psi. The pressure indicated on the gauge is merely a measurement of hose and fitting resistance throughout the system as fluid travels back to tank. Notice on the controls that the compensator indicates a setting of 500 psi. How can we prove if that label is correct? Let's tighten the setting of the needle valve to cause greater circuit resistance. Naturally, this causes our system pressure to rise. Just after passing the 400 psi mark, we notice that the pump's pressure compensator has become active. Also notice that the swash plate is now moving, and notice that the flow meter indicates less than full value. Remember, we started out with 10 gallons per minute. As we continue to tighten the needle valve, we eventually arrive at a circuit pressure of 500 psi, and we find out that the flow meter now indicates 0 flow. Naturally, there is 0 flow on the pump outlet line, as the needle valve has been closed completely. If this was a fixed displacement pump, a relief valve mounted to a T-fitting right near the pump outlet would have to divert the pump's flow back to tank in order to avoid a catastrophic overpressure condition. The pressure compensated pump is also referred to as a variable displacement pump. When there is no flow path, as is the case with our closed needle valve, the pump simply resizes itself to produce near 0 flow. The resizing of the pump is accomplished by taking pump outlet fluid and using it to extend the control piston. When the swash plate moves towards the vertical position, the individual pumping pistons in the cylinder barrel now have a near zero stroke length. The pump is maintaining 500 psi maximum system pressure on the outlet line. In every piston pump, some fluid is leaking internally between close-fitting parts. When the swash plate is perfectly vertical, this leakage causes the system pressure to drop slightly. The spring inside the pressure compensator pushes the spool downward to the closed position. This allows the bias spring to push the swash plate back towards the maximum angle, which would increase the stroke length of the individual pumping pistons. But since the needle valve is still closed, and there is no flow path available, system pressure quickly reaches the setting of the pressure compensator spring, and the control piston once again moves the swash plate towards the 0-degree angle where no pump outlet flow occurs. The action of the pressure compensator is essentially maintaining a constant pressure. If the hydraulic system requires a top system pressure of say 1000 psi, we will need to adjust the pressure compensator spring. This adjustment needs to be made when there is no flow possible on the pump's outlet. In many systems, it simply requires one to stop operating the directional valves. In this system, we have a closed needle valve, so we are ready to make the adjustment. With a pressure gauge available on the pump outlet line, simply turn the adjustment screw to compress the spring until the desired maximum system pressure is reached. When we open the needle valve, pressure will fall and the pump will return to maximum displacement due to the force of the bias spring. That is the meaning of the bias spring. The bias spring means that the pump has a tendency to produce maximum flow whenever possible. As you can see, when there is an easy flow path for the pump's displacement, changing the setting of the pressure compensator spring has no impact at all on system pressure. In a real-world hydraulic system, the maximum system pressure limit would now be unknown. This could easily become a dangerous situation. The pressure compensator adjustment must be set with the pump running and when there is no system flow occurring. In this video, we have covered the basic function and adjustment of the pressure compensator. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.